All right, guys, as we move on here in section 4.6, the next thing I'm going to ask you to do is to take a look at this particular quadratic equation right over here, and the directions kind of tell you where we're going here in the rest of this section. We are going to solve this equation here by factoring a perfect square trinomial. So I've already given you a hint here that what we have over here on the left side is a PST, a perfect square trinomial. And we probably better have a conversation here, guys. This was something, again, you were supposed to learn back in Algebra 1, but you kind of blew it off. And we talked about it here in section 4.4, and a lot of you blew it off then as well. So let's see if it sticks this time. What is a perfect square trinomial? Well, a perfect square trinomial comes from taking a binomial, like I'm going to go with 5x minus 3, and squaring that binomial. Let's see what happens when we multiply that out. First things first, guys, you cannot just distribute an exponent into a binomial base. What it means to square something is to multiply it by itself. So I'm going to multiply 5x minus 3 times itself, 5x minus 3, and now hopefully you see that this is binomial times binomial, and this is when we like to do FOIL, or what some of you call the double distributive property. So here we go. The first factor of each, the first term I should say, in each binomial gets multiplied together. 5x times 5x is going to get you 25x squared. Then the outer product is 5x times negative 3. That right there, 5x times negative 3, is going to get us a minus 15x. Okay, got it. What's next then? The inner product is this one right over here. Negative 3 times 5x is also negative 15x. That's not a coincidence, guys, because it's really the same two numbers you're multiplying. So every time you square a binomial, these two terms will end up being identical. And then the L in FOIL last is this number multiplied by this number. Negative 3 times negative 3 is going to get us a positive 9. And as is usually the case, the two terms in the middle are alike and can be put together. So we end up with 25x squared minus 30x and plus 9. Now this trinomial that we just came up with, everybody, is a perfect square trinomial. And we know this because it started life as a single binomial squared. That's where the perfect square comes from. Now, the way you can identify a perfect square trinomial is this. The first two parts are easy. The third's a little complicated. First question, is the first term a perfect square? Yes, it is. And in fact, let me write this down. The square root of 25x squared is 5x. Kind of like that 5x right there. Second question, is the last term a perfect square? The answer here is yes. The square root of 9 is 3. Kind of like that 3 right there. And now here's the weird part. The middle term in a perfect square trinomial has to be the product of this perfect square, the square root of the first term, times the square root of the last term, which is 3, and always times 2. And that's because the outer and the inner products always ended up being exactly the same. Now let's see what happens there. 5x times 3 is 15x. 15x times 2 is 30x. And if that matches the middle term, either positive or negative, doesn't matter right there. If that matches the middle term in your trinomial, then this trinomial is a perfect square trinomial. So back to this example. Now, I already told you this first one was a perfect square, but let's check it. Is the first term a perfect square? Yes, it is. And its square root is 2x. Is the last term in the trinomial a perfect square? Yes, it is. Its square root is 1. And we always multiply that by 2. And let's see what we get. 2x times 1 is 2x times 2 is 4x. And sure enough, that matches your middle term. So that's how we know for a fact, you guys, that 4x squared plus 4x plus 1 is a perfect square trinomial. And the whole point of a perfect square trinomial is that it factors very quickly into a single binomial squared. Now, what is that binomial? You've already answered this question. The square root of the first term goes here. The square root of 4x squared is 2x. the square root of the third term goes right here. The square root of 1 is 1. And now, whatever sign that b value is there comes right down here. So that is 2x plus 1 quantity squared that equals 49. So that is how you can use a perfect square trinomial, factor it now into the binomial squared, get it equal to 49, and now solving this becomes, that's not what I wanted to do, solving this becomes identical to what we just did in the previous video. The last thing happening now on the left-hand side is the square, and we will undo that by doing a square root of the left and a square root of the right. So we end up with 2x plus 1 is equal to, and the square root of 49 is plus or minus 7. We need to have both of those answers there. Then we have to get rid of the plus 1 by subtracting 1 from each side. So now we're going to get 2x equals, and let's do positive case first here, guys. Positive 7 minus 1 is 6. But then there's an or there, and now we need the negative case. 2x equals, now we look at negative 7 minus 1, which is negative 8. Okay, got it. And then, yeah, I can cram this in here. Now we solve each one of these equations individually. We divide both sides by 2 here, and we end up with x equals 6 divided by 2 is 3. Or, onto the second equation, we also divide by 2 on both sides, and end up with x is equal to, and that is a negative 4 right there. Let's get that right. X is equal to negative 4, and there are your two solutions to this equation. Okay, so if I were to test them real quick, oh, how easy is this to do? If I put the 3 back in here, let's take a look. 3 squared is 9 times 4. That makes 36. Got it, 36. Plus 4 times 3 is going to be 12. Plus 1. Well, let's think about that, guys. 36 plus 12 is 48. 48 plus 1 is 49. That's a check. A little harder with the negative, but it still works. Negative 4 squared is 16. 16 times 4 is 64. Then it would be plus 4 times negative 4, which is actually a minus 16, and we'd add 1 to that also. 64 minus 16 is 48. 48 plus 1 is 49. That's what we needed, so that one works as well. So if you can learn to recognize that a quadratic trinomial might just be a perfect square trinomial, now this ends up working out pretty nicely. We're going to get more practice at that skill here pretty soon, so I'm going to move on. Now, this is something they want you working on right here. Fill in the blank to create a perfect square trinomial. So the first one we have here is x squared plus 10x plus some number here at the end. And we're trying to figure out what number goes right here so that this trinomial is in fact a perfect square trinomial. So how are we going to figure that out? Okay, guys, this is where things get really important here. What we're going to do is take a look at this b term right here, which in this case is 10. And the number that goes here is going to be b divided by 2, and then we're going to square that result. B over 2 squared. So in this first example, our b value is 10. So 10 gets divided by 2 to make a 5, and then we square that 5, and we get a 25 here that goes there. X squared plus 10x plus 25. That, everybody, is a perfect square trinomial that we could then factor. And they might ask you then to factor it. So here we go. The square root of x squared is x. The square root of 25 is 5. Whatever that sign is right there is the sign you use, x plus 5, and that quantity gets squared. So if they ask you to actually factor it, that's how you would do it. Same concept here on example B, although I threw you a curveball here that you're not going to like. Now, B is an odd number. So, when I ask you to do this little trick here on example B, you end up taking negative 11 over 2 and trying to square that. Now, what most of you guys want to do is go to your calculator and figure out what negative 11 over 2 is as a decimal, and that will work. That's negative 5.5, but the next problem is none of you knows what 5.5 squared is without needing your calculator again. And as I've been trying to tell you guys all year, fractions are actually better than decimals because this can be done by hand. To square a fraction, all you do is square the numerator and then square the denominator. So up on the top of this fraction, 11 squared is 121. Ooh, and a negative times itself is positive. So that's 121. And down on the bottom, 2 squared makes 4. That's it, guys. 121 over 4. I know it's ugly, but that's your answer there for how to make this one a perfect square trinomial. And that would factor into what binomial squared? Well, what is the square root of x squared? Just x. I know this looks hard, but it's not. What's the square root of 121 over 4? The numbers you squared to make that were 11 over 2. And whatever sign you have right here for b, that's the sign you use right here. So it's x minus 11 halves, quantity squared. All right. So that, guys, is all of the prep work we needed to do. Now let's dive into how to actually solve equations by completing the squares. So here we go. I'm going to start you right off the bat and tell you here that the first step to completing the square is weird. It is different. In fact, it's kind of the opposite from what you did at the beginning of a factoring problem. And also, it's different from what you're going to do when we learn the quadratic formula. The first step you're going to do is get this c term and bring it to the other side. We're going to do that by subtracting 21 from both sides. And I know that looks and feels weird. So what do we have here, guys? We have an x squared, a minus 10x. And you want to leave some room here, everybody. Equals, and now my right side, 0 minus 21, is negative 21. Okay, and at this point, this problem becomes like the two that we just did. In fact, I think it's exactly like the first one we just did, almost, with that 10 right there. So how do we complete the square? We take b, which is 10, we divide it by 2, and then we square the result. 10 divided by 2 is 5. 5 squared is 25. Now, it's always a plus here, and we put a plus 25 right there, and that is how we've made ourselves a perfect square trinomial. Now, hang on. You can't just add 25 on the left side of an equation just because you feel like it, unless you also balance that out by adding 25 to the right side of the equation as well. The golden rule of algebra, you guys, do whatever you want to the left-hand side as long as you do the same thing to the right side as well. Okay, where are we now? The whole point of this is that we have now created right here a perfect square trinomial, which factors into a single binomial squared. And what is that binomial? We take the square root of the first term, which is x, and we put that right here. We take the square root of the last term, which is 5, and we put that right there. And whatever sign this is right here, we bring it right down. So x squared minus 10x plus 25 factors into x minus 5 quantity squared. And while we're at it, guys, still have an equal sign, you've got to clean up your right side. Negative 21 plus 25 simplifies to 4. And now, I'm hoping you're having your Karate Kid, Mr. Miyagi, wax on, wax off, aha moment. Where we are right now is where we were, on a problem maybe like this that we did way back in the day. Now, we are down here, guys, to an equation that only has one x in it. And we can solve that using inverse operations. The last thing being done on the left side is the square. We will undo that with a square root on the left and a square root on the right. So the square and the square root cancel out, and we end up with x minus 5 is equal to, and the square root of 4 is 2, but it's also negative 2, so plus and minus 2. Last thing, how do we get rid of a minus 5? We add 5 on both sides. Those cancel, and we get x equals, let's see if we can do this in our heads. Looking right here, guys, let's look at the positive case first. Positive 2 plus 5 is 7. That's one solution. Or x equals, now let's look at the negative case. Negative 2 plus 5 is 3. Those are the two solutions to this quadratic equation. X is equal to 7 or x is equal to 3. And let's check them both real quick and see if they work out. How about 7? 7 squared is 49 minus 10 times 7 is 70 plus 21. Well, 49 minus 70 is negative 21 plus 21. Yep, That equals 0. So the x equals 7 checks out. And how about the 3? I'll do that underneath here. 3 squared is 9, minus 10 times 3 is 30, plus 21. Well, 9 minus 30 is negative 21, plus 21 is 0. That one checks out as well. So we ended up with two distinct solutions here to this quadratic equation, which we got by the method of completing the square. So, how deep do I want to get into this? Because the two solutions we came up with were actually rational numbers, that means, everybody, that we could have solved this quadratic equation by factoring. I don't know if anybody looked at it, but that one factors pretty quickly into x and x. Signs are the same and they're both negative, and two numbers that multiply to 21 and add up to 10 would be 7 and 3. And then if you set each one of those factors equal to 0, you get x equals 7 or x equals 3, the exact same solution that we got doing it this way. So if you're asking yourself, why would I bother doing it with completing the square when I could just do it by factoring, you're 100% right to be thinking that way. Given your choice here, you would much rather do these problems by factoring. But unfortunately, you guys, it's kind of a little segue into where we're going next, factoring doesn't always work. So we're going to get into some of those here pretty soon, although you know what? I think this is an example where factoring still does. But regardless, we need practice at completing the square. So let's take a look at it. X squared plus 12x minus 13 equals 0. Step number 1, get c out of the way. So we're going to add 13 on both sides of this equation here. Those cancel. And we now have x squared plus 12x. Leave yourself some room, equals, and a 0 plus 13 is 13. Now, our job is to figure out what to add here to make this right side become a perfect square trinomial. So, here we go. We take our b value, which is 12. We cut it in half, which is 6. We square that number then. 6 squared is 36, and we add that on the left, but of course then we have to balance that out by adding it on the right as well. And what have we done? We've created a perfect square trinomial here on the left, which factors into a single binomial squared. So here we go. The square root of x squared is x. The square root of this 36 is 6, and whatever sign you have right here comes right down. This is now x plus 6 quantity squared. And on the right side, 13 plus 36 makes 49. And from here, it's going to feel a lot like the last one. The last thing happening is the square, so we undo that with a square root of the left and a square root of the right. Square and square root cancel. And we get x plus 6 is equal to, the square root of 49 is plus or minus 7. And the last thing we need here is to subtract 6 from both sides. Those cancel, and we're going to get x equals, all right guys, looking right here, positive case first. What is positive 7 minus 6? 1. And there's another answer as well. Now we look at the negative case. What's negative 7 minus 6? That's going to be a negative 13, and those are your two solutions to this quadratic equation. So, all right, we went through that one pretty quickly there, guys. Once you get the hang of completing the square, it's not really all that bad. Now, both of the last two problems, though, we ended up with rational solutions, which means we could have done these ones by factoring, but they don't all work out that way, although, I think another one I've given you here, I think this one does. All right, well, little practice won't kill us. All right, again, let's bring that c value to the opposite side by adding 10 in both cases. So let's get rid of that here. Oh, I know why I gave you this one. X squared minus 9x, leave some room, is equal to, and the 0 plus 10 is a 10. Okay, here's where life gets harder now. To figure out what number goes there to complete the square, we take half of b, square it, and add it on both sides. And in this case, everybody, b, is an odd number. So we are going to take negative 9 divided by 2, and we're going to square it. And as I told you guys earlier, I really don't want you going to your calculator and using a decimal right here. Deal with the fraction. Negative squared is positive, 9 squared is 81, and the 2 squared on the bottom is 4. So I know it's ugly, but we're going to add an 81 over 4 here on the left-hand side. And while we're at it, we're going to add the same number, 81 over 4, on the right side as well. And I want to show you guys how to deal with this. It's probably not as bad as you're thinking. All right, here we go. This is a perfect square trinomial, so it factors into a single binomial squared. And what is that binomial? The square root of the first term is x. The square root of the last term, the one we just added, is 9 over 2. 9 is the square root of 81. 2 is the square root of 4. And whatever this sign is right here, it comes right down, and we put a minus in this case. So x minus 9 halves, quantity squared, is equal to... Now here's another spot that's going to bother some of you guys. How do I add 10 plus a fraction like 81 over 4? Yes, your calculator will do this for you, but here's a way to do it by hand. You need a common denominator to add these two fractions together, and that 4 is going to be our common denominator. So we need to express 10 as a fraction over 4. And just remember, guys, that a fraction is a division problem. What number divided by 4 is equal to 10? That's going to be 40. So 40 over 4 plus 81 over 4, you just add your numerators together and get 121, and the denominators stay the same. That's going to be 4. And maybe you notice something cool about the numbers 121 and 4. At any rate, here we go. We undo the square by doing the square root of the left and the square root of the right. The square and the square root cancel, and we get x minus 9 halves is equal to, all right, every square root is going to be plus and minus, and now we just take the square root of the numerator and the square root of the denominator. The square root of 121 is 11. The square root of 4 is 2. So without a calculator, that really wasn't as bad as we thought it might be. Last thing we need to do to get x by itself, we're going to add 9 halves on both sides. And what I'm going to do here, guys, let me put it here, actually. I'll cram that in. 9 halves plus or minus the 11 halves. Okay, so x equals, and I think I better zoom out here just a little bit so we can see this going on. All right, positive case first, everybody. 9, and I'm looking right here, plus 11 is going to be 20 over 2. Or now we worry about the negative case right here. 9 minus 11 is negative 2 over 2, and then we simplify each one of these answers. 20 divided by 2 is 10, or right over here, x equals negative 2 divided by negative 2 is positive 1. All right, I just goofed something up and I saw it right there. The 2 plus the 2 right there would have given us a positive 2 down there, not a negative, I'm sorry. So x is equal to negative 1. All right, and there are our two solutions now to this original equation. And since I almost goofed that up, I should probably check this to make sure I'm right. Let me put the 10 in first. 10 squared is going to be 100 minus 9 times 10 is 90. Minus 10. 100 minus 90 is 10. 10 minus 10 is 0, so that one checks out. How about negative 1 now? Negative 1 squared is 1. Minus 9 times negative 1 is plus 9, and then a minus 10 at the end. That's 10 minus 10. That's 0 as well, so that negative 1 checks out also. All right, guys, so those are 3 nice examples. I like those a lot here, but at some point, the plot starts to thicken. And this is actually not an example you guys are going to enjoy, but this shows you why learning another method was necessary. Because if you were to try to solve this don't write this down, if you were going to try to solve this quadratic equation by factoring, it just doesn't work. X and x, the signs are different, so it's 1 plus and 1 minus, and the only way to break up 3 would be 3 and 1. Well, that's a plus 3x minus x. That's a plus 2x, not what I needed right there in the middle. so it's not 3 and 1. The only other thing we could have tried was 1 and 3. That's a minus 3x plus x. That's a minus 2x. Not what we needed there either. This is an example, you guys, of a quadratic equation that does not factor. And what that tells me, you guys will hopefully get the hang of this pretty soon, this is the first one we're going to see that has irrational solutions. And you can't get irrational solutions by factoring. Okay, let's talk about what we're going to do here, guys. Treating this like the last couple problems, we get rid of c by adding 3 on both sides. All right, those terms cancel here, and we get x squared plus 5x, leave some room, is equal to 3. Now, we have to complete the square, and I was mean to you guys again. I gave you an odd b value, but let's practice it. You take 5, you divide it by 2, and you square it. So all we're going to do is square the top and the bottom of that fraction. 5 squared is 25, 2 squared is 4. That is what we are adding to the left side, plus 25 over 4, and we add the same number here on the right as well. Okay, in so doing, we have created a perfect square trinomial, and here's how that factors into a single binomial squared. What's the square root of x squared? That's going to be x. What's the square root of 25 over 4? 5 over 2, and since that was a plus, this is a plus here as well. Now on the right side, we have to add 3 plus 25 over 4. So that 3 is what number divided by 4? That's going to be 12. 12 divided by 4 is 3. And 12 fourths plus 25 fourths is going to be this ugly fraction of 37 over 4. Okay. Now, let's get x by itself. We get rid of the square by doing the square root of the left and the square root of the right. The square and the square root cancel each other out, so we have x plus 5 over 2 equals, okay, and here's where something interesting happens. When you go to take the square root of a fraction, I told you guys before to just take the square root of the top and the square root of the bottom, but unfortunately, 37 is not a perfect square. So I'm still going to do the same thing I just said. I'm going to break that down into the square root of the numerator over the square root of the denominator. Now, since 37 is not a perfect square and it doesn't have any perfect square factors other than 1, you can't do anything with it other than leave it as the square root of 37. However, down on the bottom, the square root of 4 simplifies very nicely to 2. And don't forget, guys, every time we take a square root, there's a plus or minus that goes in front of that. So that's as nice as you can make that right side, which really isn't very nice. And now we're going to get x by itself by subtracting 5/2 from both sides of this. Now the work is pretty much done here, guys. I just want to show you how to express this answer right here. Those two terms cancel each other out, and now, okay, let's go here and here. There we go. We end up with an x equals, and you're not going to be able to combine like terms here because of the radical. So the way we would write this, everybody, the negative 5 goes right here out in front, and then plus or minus the square root of 37. But these fractions do have a common denominator of 2, so we just put that on the bottom. And guys, this sounds like bad news, but it's actually good news for you. There is nothing else you can do to clean up this expression. That is your final answer to this example here. And unfortunately, you guys, that answer is such a messy, irrational number, we really can't put that back into the original equation and check it to make sure that it works out. But that's the answer there to example D. Okay, so these problems are starting to get a little bit tougher as we go through. This one was tough also because we had an odd value of b right here, so we had to deal with fractions, but also we ended up with a number over here that was not a perfect square. Okay, now things get even tougher right here. For number 4, 3x squared plus 8x plus 50. Okay, the big difference here in this example compared to the ones that we've done before is that we now have an a value other than 1. So that creates a whole new problem. Unless we deal with it right off the bat by doing something quick and easy, we are going to divide every term in this entire equation by 3, including the 0 over here, although that's one that, in this case, you can get away with. Now, those 3's cancel. So we now have x squared plus, boy, and I wasn't very nice to you guys at all when I wrote this problem, 8 doesn't divide evenly by 3. So you end up with 8/3 x. And then plus, 50 doesn't divide by 3 either. So plus 50/3 equals, and 0 divided by 3 is just 0. So now at least we have an a value of 1. We're going to move c over to the right. So minus 50/3 on both sides. And that'll get us x squared plus 8/3 x, and then a blank, is equal to, and we've got a negative 50/3 there on the right side. So now we need to figure out what to put right here. And the way we do that, just like before, guys, is we take our b value and we divide it by 2. Now, I'm going to show you guys 2 ways to handle this right here. So we need half of 8/3. The easiest way to do that, you guys, is to just cut the numerator in half. Half of 8 is 4, and the denominator stays the same. So half of 8/3 is 4/3, and then we're going to square that to end up with 16/9 here. So we're going to add 16/9 to the left side, and we'll balance that out by adding 16/9 to the right side. Doesn't really look like it, but that is a perfect square trinomial. So it factors into a single binomial squared. What's the square root of x squared? X. What's the square root of 16/9? That's going to be 4/3, and with that plus, we put a plus right here. So the left side becomes x plus 4/3 squared equals, and I wouldn't mind at all if you guys went to your calculator here and put that one in there. But this one, let's see, your common denominator would be 9, so that's negative 150/9 plus 16/9. Now we end up here, guys, with a negative 134/9. And I just realized something weird is about to happen. All right, we would go to do the square root of both the left and the right side. And what happens? The square and the square root cancel, so we end up with x plus 4/3 is equal to, and the fact that we are now trying to take the square root of a negative number, this is going to involve something called imaginary numbers, which we haven't talked about yet. So what I'm going to show you guys here is correct. Don't worry about how I'm getting it. We will talk about this later on in the chapter. But this right side now becomes plus or minus, and oh boy, this is going to be, we'll explain later, I times the square root of 134. The I stands for the imaginary number that you get when you try to take the square root of a negative 134. And on the bottom, the square root of 9 is just 3. Okay, don't panic about that I for now, guys. And then we'll subtract a 4/3 from both sides. So the final thing I would do here, everybody, to try to, let me do this and this. All right, to try to get that x by itself here would be to write this as x is equal to, those terms cancel out. And I would write this as a negative 4 out in front, plus or minus I times the square root of 134 all over 3. That problem got uglier than it should have right now, so I don't want you guys to panic too much about where the I came from. But I did want you to see in that example how you handle it when you have a leading coefficient other than 1. We had to divide out that 3 right off the bat, and then we were able to proceed, even though that problem was pretty ugly. All right, and I had one more I wanted to do with you guys, but you know what? I think we're going to cut that one off, and I'm not going to do this one with you either. So that's probably long enough here on 4.6 on how to do completing the squares. So let's dive into that homework and see how it goes, and let me know when you guys have questions. Good luck, everybody.